Somewhere on the internet right now, a headline is spreading that claims a machine has shattered a telescope. Not physically, not with force, with something stranger, an idea repeated so many times in so many different disguises that millions of people now believe it happened. But here's the question nobody's asking. If it never happened, who made it? And why does it keep coming back, video after video, month after month, always with the same words, the same shock, the same fake certainty? That is the real story, not a telescope, not a quantum chip. A machine built to manufacture belief. And once you see how it works, you will never watch a viral science headline the same way again. Let's start with what is real, because the real story is stranger than the fake one, and it deserves to be told properly before we go anywhere near the manufactured version. In December 2024, Google's quantum computing division released a new processor chip called Willow. This was not science fiction. This was a physical piece of hardware built in a lab, tested against a very specific kind of mathematical problem. The kind that ordinary computers, even the fastest supercomputers on Earth, are catastrophically bad at solving. Quantum computers exploit a property of subatomic particles called superposition, where a bit of information doesn't have to be locked into a strict 0 or a strict 1. It can exist in a blended state until it's measured. Multiply that across enough particles, and you get a machine that can explore an almost unimaginable number of possibilities simultaneously, instead of one at a time like a classical processor. On one narrow benchmark task, Willow completed a calculation in under 5 minutes that Google claimed would take a conventional supercomputer longer than the current age of the universe to finish. Read that again. Longer than the age of the universe. That is not a metaphor Google invented for marketing. It is the kind of number that sounds like science fiction because the math genuinely produces numbers that large when you're comparing exponential problems. But here's where it gets more interesting, and where the responsible version of this story pulls back from the hype. Willow also solved a problem that had haunted quantum computing for over 2 decades. Error correction. Quantum bits, or qubits, are notoriously fragile. The tiniest vibration, the tiniest fluctuation in temperature or electromagnetic interference can corrupt the information they're carrying. For years, the assumption in the field was that as you added more qubits to make a more powerful machine, you also added more chances for errors to creep in, meaning bigger quantum computers might actually become less reliable, not more. Willow demonstrated the opposite. As Google scaled up the number of qubits on the chip, the error rate went down exponentially instead of up. This is called achieving a state below threshold, and physicists had been chasing it since the mid-2000s. Think about what that means. It means the fundamental barrier that made large-scale quantum computing seem like a distant fantasy may have just been breached in a real, replicable, peer-reviewed way. And yet, and this is the part every clickbait video conveniently leaves out, Google itself, in its own official statements, was blunt about the limitations. Willow cannot break modern encryption. It cannot simulate a full human brain. It cannot decode alien signals, reveal hidden dimensions, or outperform a space telescope, because a space telescope and a quantum processor are not competing in the same arena at all. One gathers photons that have traveled across billions of light years of empty space. The other manipulates probability states of subatomic particles inside a refrigerator, colder than deep space itself. They are not rivals. They were never rivals. This is not chaos. This is not a battle between two technologies. This is two completely different tools built for two completely different jobs, and understanding that distinction is the first crack in the wall of the fake story you've been sold. So if the truth is this contained, this careful, this hedged with real scientific caution, where did Google's quantum AI just shattered the James Webb Telescope come from? What most people are not seeing is that this headline did not emerge from a lab. It emerged from a pattern. And once you understand the pattern, you start seeing it everywhere. Here is what a search into this exact phrase reveals, and it should unsettle you. There isn't one video making this claim. There are dozens, spread across different channels, different upload dates stretching from March 2025 through October 2025, different narrators, sometimes even different fake experts quoted. And yet the underlying structure is almost identical every single time. Google's quantum AI scanned James Webb Telescope data, uncovered a nightmare. A quantum AI analyzes most disturbing signal ever detected by James Webb Telescope. Google Quantum Lab claims. James Webb images reveal signs of an invisible dimension. Google's quantum AI just outperformed the James Webb Telescope. Scientists stunned. Same telescope, same quantum branding, same escalating language of nightmares, disturbances, and stunned scientists. But here's where it gets worse. One of these posts doesn't just exaggerate, it fabricates. It invents a named physicist, attaches a fake institutional title, and puts words in his mouth that were never spoken to make a fictional discovery sound peer-reviewed. That is not journalism. That is not even hype. That is the deliberate construction of false authority, built for one purpose only, to make you stop scrolling. This is where the story stops being about telescopes and starts being about you. About the mechanics of what's actually happening inside your own attention when you see a headline like this. Understand what these creators actually know, because they know it better than most viewers ever will. They know that human curiosity responds most powerfully not to information, but to the gap between what you know and what you almost know. A closed loop bores the brain. An open loop, a mystery dangled just out of reach, activates something closer to compulsion, so they build the headline to create that gap deliberately. They take two words that already carry enormous cultural weight on their own, quantum, which sounds like magic wearing a lab coat, and James Webb, which has become shorthand in the public imagination for humanity glimpsing the literal edge of creation, and they collide them together with a verb of violence, shattered, decoded, outperformed. The word choice is never accidental. It's engineered to trigger a specific emotional reflex, the feeling that something sacred has just been broken and you need to know how. And this is where everything changes, because once you see the machine behind the message, you start noticing how many other viral science stories follow the exact same blueprint. Notice how none of these titles ever say what was actually found. They promise a nightmare, a disturbance, an invisible dimension. But the specific content is always withheld until you click, and even then, it stays vague enough to be unfalsifiable. A geometric structure the size of a solar system, structured radiation patterns suggesting artificial origin, correlations with Voyager 1 and the Candra Observatory, a possible Dyson sphere. Notice something about every single one of these claims. They are enormous, world-altering, civilization-changing, and yet somehow none of them ever made it into an actual peer-reviewed astrophysics journal, a NASA press release, or a statement from the Space Telescope Science Institute, which operates JWST and would be the first to confirm or deny something this seismic. If Google's Quantum Lab had actually found evidence of an extra dimension embedded in cosmic images, that would not stay contained to a handful of YouTube channels with dramatic thumbnails. It would dominate every scientific outlet on Earth within hours. The real story is that silence from legitimate science is itself the loudest evidence against the claim. But let's go one layer deeper, because there's a more uncomfortable question buried underneath all of this, and it's the one that should actually worry you. Why James Webb specifically? Why not some other instrument, some other agency, some other target? According to informed pattern analysis of how misinformation content clusters online, the answer is almost mechanical in its cynicism. James Webb Telescope content performs extraordinarily well in search and recommendation algorithms because it sits at the intersection of three of the most reliably clickable topics on the internet: space, mystery, and the unknown. It launched in December 2021, positioned nearly 1 million miles from Earth at the second Lagrange point, and it has spent every year since delivering images so strange and so beautiful that they already feel like they're brushing against something beyond ordinary comprehension. Deep field photographs showing thousands of galaxies in a patch of sky smaller than a grain of sand held at arm's length. Infrared views piercing through cosmic dust to reveal stars being born in nurseries light years across. The telescope has already primed the public to expect the extraordinary from it. That expectation is not something these channels created, it's something they harvested. Combine that primed audience with the second most reliable clickbait engine on the internet, artificial intelligence, and specifically the phrase quantum AI, which fuses two buzzwords the general public associates with power beyond human comprehension. And you have engineered virality. Not accidental virality. Engineered. The creators didn't stumble onto this combination. According to the pattern of near-identical uploads across nearly a year, spanning March through October 2025, with new variations still appearing, this looks like a deliberate content template, copied and reused by multiple channels, each one swapping in new adjectives: nightmare, disturbing, invisible, stunned, while keeping the exact same underlying skeleton. Think about what that means for how much of what you consume online is not organic curiosity being satisfied, but manufactured curiosity being sold back to you as revelation. And here's the part that should genuinely unsettle you, because it isn't really about space or quantum computing at all anymore. It's about trust erosion. Every time one of these videos racks up hundreds of thousands of views with a false premise, it doesn't just mislead the people who watched it. It quietly poisons the well for real science communication. When an actual legitimate discovery does eventually come out of quantum computing research, or an actual anomaly does turn up in JWST data, and there have been genuine, real anomalies flagged by actual astronomers, things like unexpectedly massive early galaxies that challenge current models of cosmic formation, the public's ability to distinguish that real signal from the manufactured noise gets weaker every single time a fake nightmare discovery video goes viral. The wolf cry effect isn't hypothetical here. It's measurable in how skeptically real science now has to fight for the same attention that fabricated science claims for free. So let's talk about what's actually, verifiably happening at the frontier of both these fields, because the true story doesn't need exaggeration to be compelling. It just needs to be told properly, which is precisely what these viral videos refuse to do. On the telescope side, JWST has spent its operational years since 2022 doing exactly the job it was built for, capturing light from galaxies so distant that we are seeing them as they existed hundreds of millions of years after the Big Bang. It has found galaxies that appear too massive, too mature, too structured to fit comfortably inside current models of how quickly the early universe should have been able to build them. A real puzzle that working astrophysicists are genuinely wrestling with, no quantum computer required. It has captured detailed atmospheric spectra from exoplanets, hunting for molecular signatures that might indicate habitability, though nothing resembling confirmed extraterrestrial life. Its findings are published, debated, occasionally revised, and folded into the slow, unglamorous, unbelievably rigorous process that is actual astrophysics. There is no nightmare. There is no invisible dimension. There is just an extraordinary machine doing extraordinary patient work, one photon at a time. On the quantum side, the frontier is equally real and equally unglamorous compared to the fantasy version. Since Willow's below-threshold breakthrough, the quantum computing field has been focused on the excruciatingly difficult next steps, scaling up qubit counts even further while preserving that error correction advantage, building more stable physical architectures, and inching toward what researchers call quantum advantage on problems that actually matter for chemistry, materials science, and drug discovery. Not headline-grabbing cosmic revelations, but things like simulating molecular interactions that could eventually help design better batteries, better fertilizers, better medicines. Google has been explicit, publicly and repeatedly, that Willow is a hardware milestone, not a general intelligence, not an all-powerful oracle, and absolutely not a tool that has been pointed at James Webb's raw data to extract hidden cosmic secrets. There has been no closed-door symposium producing suppressed findings about extra dimensions. There has been no quote from any real, verifiable physicist confirming anything of the sort. What most people are not seeing is that the actual pace of progress in both these fields, while genuinely historic, moves at the speed of careful peer review, not the speed of a YouTube upload schedule. But here's where the story pulls back to something bigger than either quantum computing or space telescopes, something that should sit with you long after this video ends. We are entering an era where the tools capable of manufacturing convincing false narratives are becoming as sophisticated, and in some cases more sophisticated, than the real science they're mimicking. The same wave of AI advancement that produced Willow's genuine, hard-won breakthrough is also lowering the cost of producing fabricated expert quotes, invented studies, and algorithmically optimized clickbait to nearly zero. Think about what that means for the next 5 years. Think about what happens when the fabricated version of a story can be produced in minutes, dressed convincingly enough to survive a casual skim, and push through a recommendation algorithm that doesn't care whether something is true, only whether it keeps you watching. According to how these content clusters already behave, we are not looking at an isolated incident with one fake telescope headline. We are looking at a preview. And this is where the uncertainty that should genuinely stay with you begins. Because the tools that could someday fact-check content like this at scale, that could flag fabricated quotes before they spread, that could distinguish real scientific announcements from manufactured ones in real time, those tools are being built using the exact same underlying technology. The same kind of large-scale AI systems that are simultaneously being used to generate the fabrications in the first place. The same technological wave that could protect public understanding of science is the one that could just as easily be weaponized to erode it further, faster, and with far less friction than a single misleading YouTube title. Which side wins that race is not something anyone can promise you an answer to. Not Google, not NASA, not any single institution holding a quantum chip or a space telescope. It will be decided by millions of small choices. What gets clicked, what gets shared, what gets believed. Made by people who may never stop to ask the one question that actually matters every time a headline sounds too perfectly engineered to shock them. So the next time you see a title promising that a machine has shattered a telescope, or decoded a nightmare, or unlocked an invisible dimension, pause before you click. Ask where the source actually is. Ask whether a discovery this enormous would really be confined to a single unverified video, instead of dominating every scientific institution on the planet within hours. Ask who benefits from you believing it, and what they gain the moment you stop asking questions. Because the real frontier isn't a telescope a million miles from Earth, and it isn't a chip cooled colder than deep space. The real frontier is sitting right here, in the gap between what's true and what's designed to feel true. And nobody has built a machine powerful enough to close that gap for you yet. Whether one ever will, or whether that gap only widens from here, is a question that remains, quite deliberately, unanswered.